Okay, we're back with Thies van der Hoeven from the Netherlands and the Weather
Yes.
Maker, and he has a presentation for us about some of the work that he's doing.
Absolutely. Thanks again. I promised just to show a little bit why we actually set up the Weather Makers 2.5 years ago. And it was all about this project and to make it happen and to connect with people like Daniel or you, John, and all the other people. We set up a kind of organization which a lot of the people that come there either have experience or saw a lot but changed, and also are able to fully jointly work on something. And it's all about the development of Lake Bardawil, which later on ended up into the regreening of the Sinai. So what I've learned by traveling with John Liu through the Lus Plateau, talking to Miami, Jan, to Lire, a lot of the people actually explained me the Earth used to be green. We're destructing it very rapidly at the moment, which simply ends up into a very hot Earth. But there is not a real reason why we cannot restore large damaged ecosystems. One of the things which really touched me when I saw this for the first time and started to realize the story behind climate change is that roughly 1/4 of the world is now a desert, which used to be green. And if you want to feel what global warming is, go to a desert. And when the sun is out there, you will just feel the heat which is created by the lack of vegetation and water in these ecosystems. And then when I start realizing as an engineer, we can all start talking about trying to reduce our carbon dioxide emission. If you simply look at the numbers, we all know we have to start bringing down the concentration of greenhouse gases simply to survive as a species. Otherwise, we will end up with temperature rises of more than potentially 15 degrees, or sea level rises going up to 20 or 25 meters, which simply means the end of humanity. So I do go a little bit quicker through here. Here you can beautifully see in very rough numbers the difference of an arid field or a wet field. And simply just look at the difference of the production of sensible heat by the sun. And just realize the amount of energy provided by the sun towards our land. Which simply means if there's a lack of water due to the lack of vegetation, we will simply start heating up our planet. But we don't really have that perspective. And here you could actually see that water functions as an energy transporter. Because what it does, and just look at the difference of temperature there, it actually evaporates at the Earth's surface, but it condensates higher up. And where it condensates, it gives away the heat again. So there you can actually see that water functions as a positive effect on global warming. These are the graphs from Milan, which I step a little bit through here, but he showed me in very practical images for the first time that if the amount of water that evaporates from the ocean roughly remains the same, with 26 degrees in the Western Mediterranean, it's 14 grams. And it didn't really change in the past from now. But what changed is because the vegetation was gone, there was no liquid water available anymore to evaporate. The land heats up and creates winds and actually increases that evaporation. Whereas the vegetation cover and available water, the solar heat will be absorbed by evaporation, which will then again increase your water vapor content. And depending on the height, the rain will come back. And the other person that meant a lot, and I just told you about it, was John Todd and his eco machines, where leave it to nature to grow her own complexity, but create the basins for life to flourish. And she will surprise you, which she can all do. So let me quickly go to all of that image that made us set up the Weather Makers. Here you can see the Sinai. On the left, on the back image, you can see the green area, which is the Nile Delta. In the middle, you can see the Suez Canal going through it. Let me see if I can pinpoint it out. It's over here. And next to it is Lake Bardawil, which is approximately 600 square kilometers in size. And they requested us if we could do something about the aquatic ecosystem there. But straight away, when we were looking at it, we were very much triggered by these images from the satellites, where you could see the old river system still out there. And here she is being put alive. So you could see all the rivers which used to flow there. So, because I'm not too good of a writer, we started to make sketches to start explaining. So just up here, this is the cross section going from all the way up in the north, going down. The mountain range at the south of the Sinai, the biggest mountain is approximately 2,700 meters high, roughly at around 350 kilometers away from Lake Bardawil, which you can see on the right side at the bottom, where we know from soil data that the lake used to be much, much deeper than it is currently. At the moment, it's only 1.2 meters deep, where we know from historical data it used to be 20 to 40 meters deep. So we started to understand, to first of all support the people still living close to the lake, we needed to bring in some more flushing into the lake. By dredging inlets, so more tidal water would flow in, we could show that more algae would start flowing because the currents would stir up the organic materials on the lake, but also migrating fish. And I guess you just asked me, you can see that the aquatic system in the Mediterranean will actually support building up this ecosystem in that lake. And from there, we saw tremendous potential, just looking back on the historical data. Now, what we started to understand, that if we could do something with that organic material found in the lake, it would make sense to dredge more, to increase that aquatic ecosystem. And the muddy material still in the lake contains 5 to 15% still of organic matter. So we started to understand if we could process that soil, we could segregate the impermeable clay materials and segregate the organic materials. We could start building up fertile soils and also impermeable soils to start capturing the rain still falling in the highlands. And a lot of these rains now cause devastating floods, and they occur like every 5 to 7 years, where if we could just build from the clay dredged of the lake impermeable groundwater dikes or levees, we could start building up these soils. And then just looking at the models, we know that if you grow vegetation, you will start creating microclimates, cooler air temperatures just underneath the canopy, where water will more easily condensate, and maybe we can support it a little bit by fog nets to start capturing this fog and increasing the acceleration of the growth possible. And from there on, still all in Excel, we started to build up this model and simply focusing on the water cycle. And we tend to call it, what we do with the weather makers, we try to show and design a required organic infrastructure to control your hydrological cycle in a beneficial way. So simply where maybe in the lowlands you would need more reeds or mangroves to increase evaporation, and higher up you want more forest canopies to start harvesting your moisture. So looking at it in a simple way, it really opens up possibilities. And then it became a little bit more funky, because at the moment we had the whole area regreened. And I was not an ecologist, but I just started to read the first books, the beginnings of it. You always see that water cycle ends up in a circle and then going high up from the ocean, flowing up there and falling down. Now, if you could see the potential of vegetation due to the fact that it retains water on the temperature of a land area, we start to understand that if you got a desert and the sun shines, she heats up the sand and creates thermics. This will create these very rapid winds which flow over the watershed. Where if you would have an organic infrastructure which holds water and makes water available when the sun comes up to evaporate, she absorbs the energy. So the land becomes less hot and evaporates water, so she increases your water vapor content further down into your watershed. Now, very simply, if you then have less heat and a higher water concentration, you will lower your cloud condensation level. And the moment your cloud condensation level comes below your edge of your watershed, you start really restoring your water cycle. And then another interesting thing happens, because the moment you will get your first condensation of your water, what it will do, it will free out energy in the higher atmosphere by condensation. And because she does that, that air lifting of your first cloud condensation will start lifting your water further up again. And so she will start creating, bit by bit, more bigger raindrops. But we all know, if water condensates, she shrinks in volume. And now we start to understand where in a functional ecosystem, you will see the suction of sea moisture at a higher altitude. So there what she does, by condensating, she will become a bigger drop, and she will suck more moisture from the ocean. And the moment the drop becomes big enough to overgain the heating of the condensation, she will start falling and gravity will gain from it. And then we all know that if gravity starts falling, you will change the wind direction. And I'm a sailor, so I always like to sail in these areas, and for sure like the Volvo Ocean Race. And you can simply see it happening on the doldrums. So if we all start to imagine that rain can change winds, we need to zoom out a little bit further. And don't get me wrong, this was just all looking at data, how we came to these kind of larger images. On the left, you see the Sinai, where this little red cross is on there. There you can see it. And because I'm a sailor, I like wind apps. And what I saw, not in extreme events, but in the days when there was no low or high pressure close by. With other words, the sun and the shape of the earth were determining the wind flows. You saw that a lot of moisture from the Mediterranean was sucked by that Sinai, because that Sinai has a triangular shape, which is low at sea level elevation at the bottom, and she goes up to 1700 meters at the edge of the watershed. So there she was accelerating that wind speed, and the moment she got into the highest level of that mountain edge, she fell down. And she was actually sucking false air via the Gulf of Suez and the Gulf of Aqaba. So we saw a very negative cycle. And you saw that wind very fast actually injecting it into the currents of the Indian Ocean. And what we realized, if we would regreen that specific part of the world, what you see on the right side, you can flip that whole system. And do we know for sure what we have stated here? Of course we don't know it for sure. The impacts are massively big. But what we do know, if we look back at historical data, historical writings, it makes a lot of sense. And one of the reasons why we called the company the Weathermakers was that John Liu requested me to read the book The Weathermakers of Tim Flannery, which I did. And on page 66, they were explaining that 7,000 to 4,000 years before Christ, all of a sudden, they saw 25 to 35% more rainfall in Mesopotamia, which is the area of Saudi and Iraq at the moment. And when I was reading the current scientific explanation why that happened, I had to laugh a little bit. A little bit of it was of the Hubble of the Earth. The other one, it could be a tsunami. Where John and I were looking at each other, and couldn't it be that at this moment of time, which we look back at sediment core drillings around the north of Africa, where we can rather accurately state when it became a desert, because the Sahara was green already 3 times and became a desert twice. And there we saw that roughly 5,500 years ago, all of a sudden, in 100 to 200 years, it became a desert, the complete Sahara. And it was the Levant Society, or this is the hypothesis we are working on, and we just got triggered by it, is that when that Sinai fell, you can see that all of that moisture, which used to go into North Africa, simply now got connected and sucked into the Red Sea. And because that normal wind flow, which you see here, which has to do with the Coriolis effect of the Earth, the moisture of the Indian Ocean could not flow back into that Red Sea anymore and was simply pushed into Mesopotamia. So there we started to realize that if you would zoom out and look into planet Earth, yes, there are certain systems on Earth which could have a tremendous effect on local and regional wind patterns. And they indirectly will have an effect on the monsoon and all of the rest. But if we focus on the weather patterns in the lower altitude, which we can change, the potential is just crazy. Here is a little image of all the encatchment basins on planet Earth, where you can clearly see the light blue area. So normally they did this on soil data from many, many thousand years old. And they looked into what used to be the encatchment basins of the world. And what you could see here is that that light blue area, that the southern and eastern part of Europe are fully connected to North Africa and Egypt and the Nile. It actually means that the majority of the water evaporated from the Mediterranean falls down as rain in the light blue area. The gray dark areas are actually encatchment basins which are not directly connected to an ocean. So if you look here, you could see that there used to be a continental divide on the Sinai. And this is actually that black line separating the reddish Indian Ocean encatchment basin to that Mediterranean. And here you can exactly see the devastating effect of that continental divide being brought down by humanity. So here you could see that now all of that moisture is sucking away from that Mediterranean basin into the Red Sea. And what we tend to say is if you're able to reduce the surface temperature of that Sinai by vegetation and retaining and infiltrating water, you will stop reducing that wind speed, sucking away that moisture, and you will push it back into that Nile Valley. And here you could actually see, because in a lot of times people ask us, but who are you stealing water from? But what you see here on the very left side, you see that Sinai. And all of those lines, those dotted lines, are the registered bad weather systems of this area when humanity started registering it. What clearly could be seen is that because that wind is not going via the Red Sea through the Gulf of Aqaba into Turkey, you could see the Föhn effect on the larger scale occurring here in China. Second of all, you could see that the moisture being pushed from the Mediterranean into this area creates or starts up a lot of these bad weather systems all over here. So we actually tend to say that if we would zoom out and work together as humanity and understand that there are certain points on our Earth which we need to restore first to be able to restore the disturbed water vapor distribution humanity is facing right now, the effects could be tremendous. And I think this is otherwise we go into a lot of further detail than you will of the lake itself. Or do you want me also to say a bit more about that?
Well, what I'm reading from this too is from your examples is that there are some critical pinch points, just say, like the Sinai is that one area in a global scale is a rather small space that has a huge effect on other continents as it goes across in changing the wind patterns. So it seems that what you're saying that there are others of those on the globe to also be identified that are our highest priority.
Absolutely. I think, and you are actually learning me that if you cannot scale it up or scale it down, it ain't a natural system. Now, the weird thing is when we started with this, we got trapped by that Sinai, surrounded by all these deserts. But there are much more places on the Earth, and whether it's on global or regional, the impacts by looking at it strategically yes, we can pinpoint and actually start using these positive feedback loops in a much more profound way where it will help us all.
Sure. I would like to continue this, let's see here, at another time. I think that this is an incredible amount of information that you gave us and a lot of thought. And basically, I'm sure, like me, a number of people will be watching that a couple times to catch all the intricacies and the detail that you put in. So it's a wonderful presentation with that. What I'd like to do also with some of your work that you're doing is, if it's okay with you, do another time, another interview, take some more time to discuss in more detail the other projects that you're working on, and also Lake Bardawil and your work over there.
Yeah, sounds good.
All right. Well, thank you, Thies. It's very nice to see you again, and appreciate John Liu helping facilitate putting our interview together.
Yeah.
and getting this all to work. I appreciate that too, and look forward to seeing you again. And thank you again for your time. This is Thies van der Hoeven from the Weather Makers, and from the courtesy of John Liu and his facilities there. And look forward to talking to you again. And do you have any plans going immediately? Other projects that you're working on or things coming up that you can tell us about?
Well, what I told you before, we're now trying to work up starting up some smaller projects in the Netherlands, but would have all the integration of the different functions. So in the Netherlands, we're busy with 2 projects. And currently with the dredgers, we're trying to look into a larger kickoff project in Europe. But if I'm honest, and my main focus myself is on the Sinai and on Bardawil. And hopefully not too long away from now, we can really start doing it. We have some good discussions going up with Egypt, and it really feels like we need to focus on there. So my majority of the time is into Egypt.
Wonderful. Well, thank you, Thies. I appreciate your time again, and look forward to talking to you further.
Excellent. Good luck with the conference.
Thank you.
Cheers. Bye-bye.
Bye-bye. So this is Dan Halsey with United Designers and Southwoods Ecological Systems for the Global Earth Repair Conference. Thank you for taking your time to watch another one of our interviews, and hopefully we'll see you at the conference, but we'll also have these interviews up on YouTube for future reference. Until next time, Dan Halsey, we'll see you again. Thank you.